For centuries, humans have gazed at Venus with wonder, calling it the morning star and the evening star, a symbol of beauty and grace, named after the Roman goddess of love. For decades, scientists even called it Earth's sister planet, and for good reason. Venus and Earth formed 4.6 billion years ago, from the same swirling cloud of gas, dust, and rock in the inner solar system. They are nearly identical in size. Venus has a diameter of just over 12,100 kilometers, only about 5% smaller than Earth. Its mass is 81.5% of Earth's. Its density is nearly the same, and it is a rocky terrestrial planet, just like our home. It orbits the Sun at 0.72 astronomical units, so close to our orbit that it is often the nearest planet to Earth. If you looked at our solar system from light years away, you would easily mistake Venus and Earth for a pair of planetary twins, two worlds born from the same materials in the same region of space, with nearly identical physical blueprints. But if you could step onto the surface of Venus, you would not find lush forests, blue oceans, or life as we know it. You would find a living nightmare, a world so hostile and extreme that it has rightfully earned a far darker nickname, Earth Devil Sister. Today, we are going to journey deep into the terrifying secrets of Venus, a planet that mirrors Earth in every basic way, but has evolved into the most uninhabitable place in the inner solar system. We will explore its suffocating atmosphere, its scorching surface, its violent geology, the failed missions that tried to tame it, and the catastrophic story of how a once promising world turned into a hellish furnace. This is not just the story about a planet. It is a cautionary tale for Earth itself, a reminder of how delicate the balance of life really is in the vast, unforgiving cosmos. Let us start with the most shocking difference between Venus and Earth, its atmosphere. Earth's air is a life-giving mix of 78% nitrogen, 21% oxygen, and trace gases that keep our climate stable and breathable. Venus' atmosphere is the complete opposite, a thick, toxic blanket that crushes and cooks everything in its path. It is made up of 96.5% carbon dioxide, the same greenhouse gas that warms our planet, but on Venus, it is present in such extreme amounts that it has triggered the most severe runaway greenhouse effect in the entire solar system. The atmosphere is so dense that its mass is 93 times that of Earth's atmosphere, and it stretches dozens of kilometers high, shrouding the entire planet in a permanent, unbroken layer of clouds. These are not soft, fluffy water clouds like we have on Earth. They are made of concentrated sulfuric acid, the same corrosive liquid used in industrial batteries. When it rains on Venus, the droplets never even reach the surface. They evaporate miles above the ground, creating a cycle of acid vapor that makes the upper atmosphere a caustic, dangerous storm zone. The cloud tops spin around the planet at astonishing speeds, reaching more than 360 kilometers per hour, a phenomenon called superrotation, meaning the atmosphere circles Venus dozens of times faster than the planet itself spins. This thick toxic veil does more than block sunlight. It traps every single bit of heat from the sun, creating a planetary oven that never cools down. The results of this runaway greenhouse effect are nothing short of apocalyptic. The surface temperature of Venus is a constant 462 degrees Celsius, day and night, at the equator and at the poles. There is no escape from the heat, no seasonal change, no cool breeze. This temperature is hot enough to melt lead, tin, and zinc. Any metal you can think of would turn to liquid on the surface of Venus. To put this in perspective, the hottest temperature ever recorded on Earth was a mere 56.7 degrees Celsius in Death Valley. Venus is nearly 8 times hotter. Even Mercury, the planet closest to the Sun, has colder nights because it has almost no atmosphere to trap heat. Venus, farther from the Sun than Mercury, is hotter because its atmosphere acts as a blanket that will not release heat. The heat is so intense that the surface glows with a dull orange-red heat, and the air itself feels like a blast from a furnace that has been burning non-stop for billions of years. If the heat does not kill you, the pressure will. At Venus's surface, the atmospheric pressure is 92 times greater than the pressure at sea level on Earth. That is, the same pressure you would feel if you dove nearly 900 meters under the ocean, a depth where human-built submarines can barely survive without being crushed. Imagine the weight of a large truck pressing down on every square inch of your body, non-stop, with no relief. This crushing pressure is so powerful that it warps metal, cracks rock, and destroys any machine that is not built to withstand extreme force. For decades, the Soviet Union tried to land probes on Venus as part of its Venera program, and even the sturdiest landers only survived for a short time. The Venera 7 probe, the first human-made object to soft land on Venus in 1970, transmitted data for just 23 minutes before failing. The longest any probe has ever lasted on Venus is 127 minutes, a record set by Venera 13. After that, the heat and pressure destroy every circuit, every sensor, every camera. No human could survive there for more than a split second, crushed, boiled, and corroded by the acid air all at once. Beneath this deadly atmosphere lies a surface that is just as hostile. For years, we could not see Venus's surface because the clouds blocked all visible light, but NASA's Magellan probe changed everything in the 1990s. Using synthetic aperture radar, Magellan mapped 98% of Venus's surface, revealing a world covered in volcanic rock, vast lava plains, and thousands of volcanoes. More than 80% of Venus's surface is made of basaltic lava flows, proof of intense, widespread volcanic activity that has shaped the planet for billions of years. There are more than 1,600 major volcanoes on Venus, and countless smaller ones that scientists have not yet counted. Some are shield volcanoes like Hawaii's Mauna Loa, while others are strange circular formations called coronae, created by hot magma pushing up from the planet's interior and then collapsing. The highest point on Venus is Maxwell Montes, a mountain range that stands 17 kilometers tall, nearly twice the height of Mount Everest. The surface is relatively young, with very few impact craters, meaning volcanic eruptions have resurfaced the planet again and again, erasing ancient scars. Unlike Earth, Venus has no tectonic plate activity, so heat from its core cannot escape through moving plates and volcanic ridges. Instead, the heat builds up until it erupts in massive global volcanic events that reshape the entire surface. Recent studies, using data from ESA's Venus Express and Japan's Akatsuki orbiter, suggest that Venus may still be volcanically active today, with eruptions happening beneath its clouds right now. One of the biggest mysteries of Venus is why it has no magnetic field, a feature that has sealed its fate as a devilish world. Earth has a powerful magnetic field generated by the churning molten iron core inside our planet. This magnetic field acts as a shield, deflecting harmful solar wind and cosmic rays that would strip away our atmosphere and make life impossible. Venus has a similar iron core, but it spins far too slowly to create a magnetic field. A day on Venus, one full rotation, lasts 243 Earth days, longer than its year of 225 Earth days. This slow, sluggish rotation means its core cannot generate the dynamo effect needed for a magnetic field. Without this shield, solar wind slams directly into Venus' upper atmosphere, slowly stripping away lighter gases like hydrogen and oxygen. But the heavy carbon dioxide remains building up in the atmosphere and making the greenhouse effect even worse over time. This lack of a magnetic field is one of the key reasons Venus could not hold onto its oceans, a topic that brings us to the most heartbreaking part of Venus's story. It was not always a hellish world. Scientists now believe that early Venus, billions of years ago, was very different. It may have had liquid water on its surface, thick clouds that reflected sunlight, and a mild climate similar to early Earth. Some models even suggest Venus could have had oceans for up to 2 billion years, long enough for simple life to develop. But as the sun aged and grew brighter, temperatures on Venus slowly rose. The oceans began to evaporate, releasing water vapor into the atmosphere. Water vapor is a greenhouse gas, so this made the planet even hotter, evaporating more water and creating a feedback loop that spiraled out of control. The hydrogen from the water escaped into space because of the missing magnetic field, and the oxygen bonded with surface rocks, removing all traces of liquid water. Carbon dioxide, once trapped in rocks and oceans, was released into the atmosphere, building up to the extreme levels we see today. What started as a small temperature shift turned into a planetary disaster, turning a potentially habitable world into a scorching desert. This is the runaway greenhouse effect in its most extreme form, and it is a future we must avoid on Earth at all costs. Our exploration of Venus has been a story of struggle and discovery. The Soviet Union's Venera program was the first to reach Venus, sending probes that endured the hellish conditions to send back the first photos of the rocky, desolate surface. NASA's Mariner and Pioneer missions studied the atmosphere from orbit, revealing the toxic composition and crushing pressure. The Magellan probe gave us our first global map of the surface, uncovering its volcanic wonders and violent geology. The European Space Agency's Venus Express and Japan's Akatsuki Orbiter have continued to study the atmosphere and climate, unlocking more secrets about how Venus evolved. Soon, NASA's Da Vinci Plus and Veritas missions, along with ESA's Envision, will return to Venus, diving into its atmosphere and mapping its surface with unprecedented detail. These missions will answer questions that have puzzled scientists for decades. Did Venus ever have life? How fast is its atmosphere changing? Can we learn enough to stop Earth from suffering the same fate? Venus stands as one of the most profound mysteries in our solar system. It is a planet of breathtaking beauty, when seen from afar, a bright, gentle light in the night sky that has inspired poets, artists, and stargazers for all of human history. But up close, it is a world of unrelenting horror, a devilish twin that shows us just how lucky we are to call Earth home. It teaches us that size and position do not guarantee habitability, that a single shift in atmospheric balance can turn a paradise into a furnace, and that magnetic fields and oceans are not just features, they are lifelines. As we look to the stars and search for habitable exoplanets, Venus reminds us to cherish the fragile, perfect conditions that allow life to thrive on Earth. It is a warning, a teacher, and a wonder, all in one. A planet that forces us to confront the power of nature and the fragility of life in the cosmos. Every time we look at Venus in the sky, we are not just seeing a planet. We are seeing a mirror of what Earth could become if we do not protect our atmosphere, our climate, and the delicate balance that keeps us alive. It is a devil sister, yes, but she is also a messenger from the cosmos, telling us to value the world we have. As we keep exploring, keep learning, and keep reaching for the stars, Venus will always be there, shining bright. A constant reminder of the fine line between paradise and perdition in the endless black of space. Please like, comment, share, and subscribe to the channel.